Humans have built bridges across every major river on Earth. The Yangtze, the Mississippi, the Danube, every single one, except one. The Amazon River has 0 bridges, not one. And it's not because no one has tried. Engineers have drawn up plans, governments have approved budgets, construction crews have broken ground. But every attempt runs into the same problem. The Amazon doesn't want to be crossed. The riverbed shifts. The water level rises 40 feet in a single season. And beneath the surface, forces are at work that can rip apart steel and concrete like cardboard. What exactly makes this river so impossible to tame? The answer is stranger than you'd expect. The first answer is size. But the real problem starts under the water. At its narrowest crossing point, the Amazon still stretches over 1 mile wide. During wet season, it can spread to 30 miles across in places. That means a bridge is not crossing a fixed line on a map. It has to cross a river that changes size by whole towns. Then the water volume turns that distance into something worse. The Amazon moves 5 times more water than any other river on Earth. Every second, 209,000 cubic meters of water push toward the Atlantic. That is enough to fill 83 Olympic swimming pools every single second. But volume alone does not explain why bridge plans keep failing. Bridge engineers need to drive foundations deep into the riverbed. On many rivers, that means drilling down until they reach stable ground. The Amazon does not give them that kind of bottom. Its riverbed is loose sediment, mostly sand and silt carried from the Andes Mountains 4,000 miles upstream. That material does not stay in place. The current digs it out, carries it away, and piles it somewhere else. A foundation poured 1 month can be exposed the next, or buried 10 feet deeper. That is the core problem. You cannot anchor a bridge to something that moves, and the shifting ground is only the first thing working against it. The water itself does something far worse. Every year, the Amazon does something no bridge engineer can fully lock down. It moves sideways. The river is not locked inside one permanent channel. It cuts into one bank while it drops sediment on the other. In some stretches, the riverbank retreats more than 300 feet in a single year. Entire sections of forest collapse into the water. Engineers call this lateral channel migration. For a bridge, it means the land holding the approach road can disappear within a few years. Then the river changes height. Between dry season and wet season, the Amazon can rise 40 feet. A bridge has to survive both versions of the same river. Low water can leave foundations exposed to damage. High water pushes with enough force to strain steel and concrete. During peak flood, the river adds one more threat. It carries full-grown trees downstream at speed. These are not small branches. Some are hardwood trees weighing several tons. When they hit a pier, the impact becomes part of the bridge design problem. Engineers call it debris loading. A design may survive one flood, but it has to survive that impact year after year. That is why the Amazon attacks a bridge from every direction. From below, the bed shifts. From the sides, the banks move. Head-on, floodwater and trees strike the structure. But the final reason no one has built the bridge has nothing to do with engineering. Even if engineers solved every physical problem, the bridge would still face one final question: who actually needs it? The Amazon basin is one of the least densely populated regions on the planet. On both banks, huge stretches are rainforest. There are no major highway networks waiting to meet in the middle. The cities along the river, including Manaus and Macapa, already use boats and ferries. That system is slow, but it fits the place. A bridge would need a reason strong enough to justify billions in spending. The closest example shows how steep that bill gets. The Manaus-Iranduba Bridge opened in 2011. It cost more than 1.2 billion reais. It took 3 years to build, and it crosses the Rio Negro, a tributary, not the main Amazon channel. A main channel crossing would be far longer and face far more force. The price would climb before the first vehicle ever used it. Then the planners would run into the same problem again. The roads on each side do not connect to a large transport network. A government could spend a historic amount of money and still connect two weak endpoints. That is why the answer is bigger than engineering. The Amazon has no bridge because the river fights construction and the region does not demand one. People have crossed every other major river with steel, concrete, money, and time. The Amazon is the one that still refuses to be crossed.